Hello, my name is Alex. Today we will start looking at loops. Loops are used in every programming language, and they are one of the most useful tools that you can use. Today we will start off by looking at the most basic type of loop, known as the for loop. The syntax in Visual Basic for a for loop, you will start off by putting for, then you have to put a variable, like for example, normally in the for loops, you have the y variable. And let's say we want to start at 0, and we want an action to be repeated until the value of y equals to 10. And then we just need to write next y. So the variable name here. In the loop, whatever is inside these two lines will be repeated the amount of times that you specify here. By default, the increment of the variable in a for loop is by 1. So if we try to do now at the book.print of the y variable, and we execute this code, you will see that, as intended, it starts at 0, and it repeats this line exclusively up until 10 times, because it's what we said. We said, hey, repeat this action until the y variable equals 10. As you might have started seeing, this gives us a lot of potential when performing very complex operational codes, or we have to do very specific actions. For example, let's say we have a variable called a, and we put that is equal to 0. And what we want to do is that a is equal to a plus the value of y. So now a equals 0 in this example. In the first part of the loop, when I is equal to 0, what we are saying here is that, hey, set the new variable of a to the value that a currently had, that in our case is going to be 0, plus the value of y in this case, that in this first scenario is going to be also 0. So a will stay the same. In the next part of the loop, when y equals to 1, this will be exactly the same, but now we are adding 1. So now the value of a will be 1. Okay? And now if we execute again, we are that y is equal to 2, so here a equals 1 and y equals 2, so now a will equal 3. For you to see this example clearer, we are going to do a debug print of the value of y. Okay, and yeah, here you can see for each y value what is the value of a. And now we do the print and the value of a. Okay. And for it to be easier to see where it's each value, we do like this, for example. And now we execute this. When I equals 0 in the first part of the loop, a will be 0. When y is 1, a will be 1. In the second part, or in this case, this is the first, the second, and the third iteration, a will be 3. In the fourth iteration, a will be 6, and so on. So you can see here a sort of potential. Also, we can combine this with other Excel functions, like for example cells, or even range, it doesn't matter. So we can do, for example, range of a, and we do y. So this means, this means it will go from A0, A1, A2, you see? But here we have an issue. In Excel, A0 doesn't exist. So we have to start the loop at the value of 1. Or, simply, we can still have the loop at 0, but we have to add 1 to the value of y here always. Okay, let's say dot value 2 and is equal to whatever value we got in y in the loop. Okay, we now run this, and now we go to Excel. Here you can see what this for did. So this for loop actually wrote in these different cells the value of y in the loop. And this was done with just one line of code. Well, actually three, because it's the for and the value inside the for and the next y. To make this a little bit more complex, and you might be able to see what is the full potential of using the for loops, we can have a for loop inside another for loop, also known as a double for. So we can do, for example, now another variable, 5, let's say like that, and next j. Okay, and now, for example, we can do cells. Let's say that in our case, we want the row value to be the y and the column to be whatever value j has. And we do the dot value 2 equals to, let's say, for example, y, and oops, sorry, this should be like this, and j. So like this, we can see what's the value of I and what's the value of j. We have to remember that we have to write a +1 here, because the cells in Excel will start at an index of 1, not an index of 0. And if we now execute this, you will see in Excel what is happening. So here you will see the potential of the double for. What the code is doing is actually, okay, I'm in the first loop of y. Okay, I have another for. I'm in the loop, in the first loop of j. Okay, I have to perform this 5 times. So he writes this 5 times, but because it's what we are telling him here, and he goes to the next value of y, and then he writes this, and so on until he reaches this point. Actually, it will be easier to see if I write to it a little bit different. Probably like this is easier for you to see what it is, the value of y and j. Yeah. So now we have, you can see here that when y equals 0 and j equals 0, we are writing here, and it does all this because, as you can see, we are still doing in the first part where y equals 0 and j equals 5, okay, and so on. Excel wrote it like this because this is how we told him to do it, because we are actually saying that y is the row, the value of the row that he has to write in, and j is the value of the column. But for example, we can write it the other way around. So we can do like this. And if we now clear this, for example, and we execute now this, as you can see, it did it the other way around. So now it wrote 10 columns wide and 5 rows high. So as I told at the beginning, by default, this value is being incremented by 1 in each loop. But you can change this behavior by using step and specifying the value. For example, let's say 2. Okay? So if you now execute this, well, sorry. If you now execute this, you can clearly see what is happening. And is that because we are saying a step of 2, for y1 it's not writing, for y3 also it's jumping this part because we are incrementing y by a value of 2. Also, as you might have guessed, you can do actually the inverse. So instead of adding, we can do a for loop in the other way around, subtracting. So actually this will be pretty much the same. And we just need to change this. And if we now debug print the value of y, here you go. Okay, and what will happen in these cases, for example, instead of telling him to stop at 0, we tell him to stop at 1? Will he actually reach 0 or will he stop when the value of y is 2? Well, in this case, obviously, it will stop when the value of y is equal to 2, because before performing the for loop, he will check to see, okay, what's my value of y? If I do another step more, will I overpass this value or not? So that's why he stops before reaching the value of 0. Okay, so now in this example, as you can see, I've increased a little bit the amount of times that he needs to be inside the loop. And if we click the run button, okay, he did the 50 values. But let's say that by any condition inside the for loop, you wish, for example, to exit the for loop prematurely before it reaches the value of 50. You can do so by using the if conditional that we learned in previous videos. Like, for example, if y equals to 25, let's say this is our condition, then exit 4, okay? And here we're going to do the debug, the print of y. If we now execute this, you will see that it will reach up to 25, and before, because we are meeting this condition, it will enter here, and the for loop will be exited. So as you can see, it will actually end before reaching the value of 50. And that's more or less it. That's all the things that you need to know of how to use the for loop.